There we go. Now I got it. So statistical inference, estimating population proportions, confidence intervals. Let's just talk quickly about this before we really get into it, because again, I kind of want to lay out this semester for you. Okay, chapter 8 has 3 sections. Most every chapter has 3 sections. Section 8.1 is confidence intervals, the basics. So I'm going to introduce you to confidence intervals, what confidence intervals are and why we need confidence intervals. We're just going to talk the basics about them, okay? And then in 8.2 and 8.3, pretty much, I'm basically just telling you how to find confidence intervals, how to find them. This is going to explain what they are and what we're doing with them. I'm going to explain how to find them in 8.2 and 8.3. But now listen, guys, that's how you find them for categorical data. For categorical data. So everything's going to be categorical in 8.2 and 8.3. Okay? So that's chapter 8 in a nutshell, 3 sections. Chapter 9 is going to start talking about hypotheses testing or significance tests, whatever you might want to call it, but confidence intervals here and then significance tests. And so it has 3 sections. 9.1 is going to introduce you to them, talk about them, what they are, what we use them for, how we do this, right? And then, not necessarily how, I guess. And then 9.2 and 9.3 is how to find significance or how to do significance tests for proportions. I'm sorry, yes, for proportions, categorical data. So 8.1, 2, and 3, introduction, proportions, confidence intervals. 9.1, hypotheses testing, how to find them, how to use them, all that kind of stuff. And then we're going to go to chapter 10, and it only has 2 sections because it's hypotheses testing for means. But you already know what they are. You've already discussed 8.1, so there's no need to do a 9.1 because a 9.1 and 8.1 would be exactly the same. The only difference is 8.2 and 10.1 is how to find them for means. You're kind of okay? So if you understand this chapter 8 really, really well, 9 is almost identical. Just like sampling distributions. Once you realize how to do a sampling distributions for categorical data, there wasn't a whole lot of difference for numerical data. It was a little bit different formula, a little bit different conditions, right? If you guys think back, I know chapter 7, it was a little rushed, but okay. And then chapter 11 is going to be hypotheses testing for means. So we go confidence intervals, hypotheses testing, confidence intervals, hypotheses testing. And there's only one more chapter after that. We only go to 12. And that's hypotheses testing. You'll kind of see how the semester is just going to be a lot of repetition. Will we still need to do stuff from the first semester? Absolutely. But all that stuff's going to be just a little bit of aha or oh yeah moments, those type of things, right? And my plan is, even with some snow days, and hopefully I don't mind having a snow day every once in a while. Even with some of those built in, we'll be done with this book by spring break. The day before spring break, we'll take the last chapter test. And that gives us all of April to review. And so I'm going to ask you to push hard for these 4 chapters, and then you guys do what we're supposed to do here, and I make it pretty darn easy for reviewing. We pretty much review in class, and that's it. I don't do much homework at all, if any. You give me that hour and a half in class, and that's all I'm going to expect you guys to do. Good enough with all that stuff? It works out pretty well. We've done it that same way for I don't know how many years, and I know by then you guys are really done. So just give me that hour and a half because I want you guys to pass the AP exam, not for me, but for you, right? Okay, 8.1, we're good? Focus in on today. I'm going to talk a whole lot more about what's happening rather than actually give you some notes. But again, make sure you guys follow along with what's happening. Confidence intervals, the basics. Confidence intervals, the basics. So how long does a battery in the newest iPhone last? Well, we have no idea. The only way to know that is what they're going to tell me. And the only way they're going to tell me is them have an idea. And of course, the only way to have an idea is probably to measure several iPhones. But you can't measure all the iPhones because if you measure all the iPhones, there's just no way to do that, right? And we also talked about in the first chapter or first semester how reliable a census was, right? Even if we did a census, it's probably not as reliable as maybe just going ahead and doing a sample. So what we're going to do is take a sample and we're going to estimate how long the iPhone battery should last, right? What proportion of college undergraduates attend all of the classes last week or last semester, however you want to say it, right? So this is numerical data, how long the iPhone battery lasts, so many hours, so many days, whatever you want to say. This is proportional data. What percent went to class? Okay with that? Just kind of see that. Again, there is no way for me to ask every single undergraduate student what percent they attended class last week. I can't do that. You can't. So we're going to take a good random sample. That's why we talked chapter 1 or chapter 4. Our very first chapter is talking about how to get random samples, good random samples, what happens if it's biased. Okay? All that stuff we kind of still need to think about, but that good random samples will lead us to populations. Uh-oh, I don't want that button. How much does the weight of a quarter-pound hamburger at a fast food restaurant weigh after you cook it? Well, you can't cook every single one of them. We can't do that. So we're going to get a sample and get an estimate of what we think the population is. That's what a confidence interval is. So again, let's talk mathematics, right? At some point in time in your mathematical career, you talked about intervals. At what point is this function increasing from here to here? Where is it decreasing from here to here? Where is it constant from here to here? Right? We talked about intervals. We always gave you intervals. Sorry, let me get a writing utensil. We typically gave you intervals like this. Every once in a while you had an interval like that, right? We don't do that in this class because it says it has to. We don't do that part of it. We always do parentheses. So that's what an interval is. You have some number lower bound and some number upper bound, and that's what a confidence interval is. It's some interval of numbers that we think the population will fit. We think the population is in it. Y'all okay? All right, beautiful, beautiful, beautiful. It wouldn't be practical to determine the lifetime of every iPhone battery, to ask all undergraduate students, or to weigh every hamburger. It's just not practical. It's not feasible. And that's why we do statistics. We do statistics, one, to get a really good idea of what we think the population is. Do we sometimes miss it? Yeah, sometimes we do. In the next two chapters, we're going to introduce the two most common types of formal statistical inferences. I'll give you this definition again in a second, but inferring to the population. Confidence intervals, chapter 8, chapter 10, 8 and 10, and then significance tests, 9, 11, 12. Okay? Both types are based on sampling distributions. We understand how sampling distributions work. We know what they are, even though we got to hit some of that again. But by the time we get done with this chapter and next chapter, you're going to understand sampling distributions. Our goal in many statistical inferences is to use a sample statistic. Remember what a statistic is. It's a value from the sample, right? To estimate that population parameter. And the parameter is a value about the population. So we're going to use p hat to estimate p, right? We're going to use x bar to estimate mu. And I say estimate, I don't think those are equal. I don't think those are equal. I think they're close, but that's why we do an interval. I'm going to use this to estimate what that is. I'm going to use this to estimate what that is. And we also know already about what? If I do one p hat, that's different than another p hat. It's different than another p hat. It's different than another p hat. Right? We also know x bars, x bars are different samples of the same size from the same population give me different results because that's sampling variability. So that's what our goal in statistics is, and that's what our confidence intervals, that's what it is. That's what we're using confidence intervals for. We're going to use a sample. Statistic typically means we don't care about the standard deviation of population. We want to know what the average is to estimate what the population average or parameter is. Everybody okay? Here we go. We've learned that if we randomly select from a sample, we should be able to generalize that to the population. Again, something we talked about earlier. It's common sense, but I do want to make sure we hit that. We've also learned that different samples yield different results because of sampling variability. Again, we understand that. How many samples are we going to take? One, we're going to assume it's a good sample. We're going to assume that we know how to take good samples, and therefore we can generalize that to the population. Statistical inferences use the language of probability to express the strength of our conclusions. So depending on what probability is how strong our conclusions are, yada, 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 no big deal. Okay, here we go. Here's your first definition. I think I gave you this in chapter 7. Again, I won't ask you what this definition is, but you need to understand is that's what we're doing from now on. We're doing statistical inferences. We are using a sample, drawing conclusions about the population from sample. We're using a sample to draw conclusions about the population. That's what inference is. I'm inferring. I'm inferencing. Okay? Statistical inference. Day 1 of this class, I told you we're going to talk about 4 major topics. One of them is the collecting of data, and we only use 1 chapter for that. Analyzing the data. That was 2 chapters, or that was 3 chapters, I guess. Chapters 1, 2, and 3. And then we talked about probability. That was chapters 5 and chapter 6. And now we're doing the inferences, and that was chapter 7 through 12. And 7 just introduced us to it. Now we're actually doing the inferring. Okay? All right. Point estimator. Here's the very first thing we're going to talk about. Point estimate. Point estimate. Point estimate. Point estimate. I got to estimate from somewhere, right? I got to start with something. So my point estimator is always going to be that statistic. Your point estimator, where we're going to start, what we're going to use is whatever that statistic is. It's going to provide an estimate of that parameter. And guys, I'm going to tell you, it's either going to be p hat, because it's a statistic, right? It's a statistic. It's either going to be p hat, or it's going to be x bar. How are we going to know if it's categorical or if it's numerical? iPhone batteries, that was numerical. Percent of students who went to class, categorical. You either went to class or you didn't go to class. You're in this category or this category. The weight of the hamburger, numerical. Okay with that? Now we will talk about one other variable. That's in chapter 12. It's a very small talked about, but do understand that we will talk about slopes. We will, in bivariate data, we'll talk about slopes. And so that would be chapter 12. And that by then, you guys are really cooked and burnt and tired and don't want to do a whole lot more, but we're still going to get it in. Okay? The point estimate is either going to be x bar or p hat. Now, tonight, for your homework, it could be x bar or p hat. But 8.2 and 8.3, it's only going to be p hats. We're only dealing with p hats because we're only going to deal with categorical data. It's easier to talk about categorical data if you guys think back to sampling distributions, right? In sampling distributions, categorical data, all I needed was p hat. That's all I needed. With means, I didn't really need p hat. I needed p either way, right? But with means, I had to have 2 things. I had to have 2 things. I had to have the mean and the standard deviation. With proportions, I don't have to have the standard deviation because the formula for the standard deviation uses that or uses that, if you guys can remember. So categorical data is a little bit easier to talk about than numerical data, and that's why we do categorical data first. So it will either be x bar or p hat tonight, and then after that it's going to be p hats, and then it won't be bivariate data until chapter 12. Okay? Easy question in the world. You hope I ask 800 of these on the test. Not really, but because you will get bored. Identify the point estimate. Okay, I'm either using x bar or p hat or b, but I'm not. Would you use to estimate the parameter in each of the following settings and calculate that value? What proportion? Proportion. You're not going to have to guess if it's numerical data or categorical data, guys. They're going to tell you. They'll tell you it's going to be proportions, or you're not going to see the word proportion, and they're going to give you numbers. Okay? Of Cheez-Its, imagine that, New Year, are not a complete square. In other words, they're smashed, crushed, cut in half. Something happened to that poor old Cheez-It. It's not a full Cheez-It. Good enough? So right now, I'm looking for that. but I don't have any information other than what they're getting ready to give me. I opened a bag of the famous delicious crackers and found that 38 out of 116 crackers were smashed, crushed, whatever, not a complete Cheez-It. So the point estimate I'm going to start off with is that. And if I have to, I can change that to a decimal. I can change it to a percent. I can leave it like that. Most of the time, we turn things into decimals just because it means something to us. I mean, most of us can figure out what that, but it doesn't mean a whole lot to us until I turn it into 30%. And now I can understand, okay, 30 out of every 100 is going to be crushed. Good enough with that? Any question? So that's what we're going to start with. Now, let me ask you something that you already know, I hope, but it came from last semester. If I took another random sample from a different bag or even the same bag or whatever, and I found 116 crackers, are 38 of those going to be smushed, crushed, whatever? Probably not, right? Because what? Different samples of the same size from the same population yield different results. Should it be close to 30? We hope. Provided I've gotten good samples, it should be close to 30. But again, just kind of remember all this stuff, right? Is it going to be the same as the population? Probably not. Probably not. However, that's the point estimate we got to start with. That's what's got to at least give us an idea of what we think it might be. Okay with that? Beautiful. Let's say we took another bag of Cheez-Its right there. We found the proportion of that to be 0.302. No, we already said it probably will not be 0.302. Probably not. If we took another sample, would it be different than the first one and the second one? Probably. We learned about that. I'd be more surprised if it was exactly the same and then if it was different. How close do we think that 0.302 is to the population? Again, we really don't know. But that's why we're trying to do all this stuff. Okay, here we go. Here's the definition of a confidence interval. I've mentioned it 3 or 4 times. Let me talk about you and give you the actual definition of a confidence interval. Now, you already told you one thing, right? It's an interval. So it has a lower bound and an upper bound. So it's an interval. There's no doubt about that. So at least we understand an interval. We know what that is. I mean, you know that from mathematics, an interval. Okay? It gives an interval of plausible. Notice that I got that bolded. Okay, that's kind of a big word. It's a big word that I did not talk about a whole lot my first probably 8 or 9 years of teaching this course. Plausible values. Plausible values of some parameter, right? It's always going to try to predict a population. So a confidence interval is some interval of plausible values of a parameter. And then we're going to say from common sense based on a sample, which, I mean, that's all I can base it off of. I have to base it off of a sample. So that's what an interval is. An interval is just that. An interval, it's a confidence interval, because we're confident or not confident, or kind of that's just what they call it, a confidence interval of plausible values we think what the population is. A couple people still writing. I'm just giving that the pause. I'm giving it the teacher pause. I learned about that in education class. Let me be sarcastic. I'm not even sarcastic. I never took an education class. Never took one. I just have a mathematics degree. I don't have a teaching degree. There's a difference, I guess. That's why I'm not a good teacher. I just know math. I have a master's in education. But I cheated in it. It was all online. I'm kidding. Maybe I'm not. Okay. You guys are brilliant. You might have an idea why I have plausible bolded, underlined, talked about it plausible as opposed to what I used to talk about, which was possible. Hit me, Riley. Talk to me.
Plausible more signifies that it's like likely to happen, and possible is just instead of anything that can happen.
So if it's possible, that means it has to be in there. Fair enough with that word? Possible values. That means it's impossible to not be in there, and that's not true. That's not true. Plausible means we think it's in there. We got a good chance it's in there. If it's in there, I'm not surprised. But if it's not in there, I am surprised. However, it's possible I missed it. Y'all okay with that terminology? So try to keep out of your head, just because I found this interval, I could have still missed it. I could have still missed it. That's why we say plausible as opposed to possible. Possible means I had to have hit it. Now, I can change it to possible. There is a 0% to a 100% chance that it's going to rain today. I can change that to possible, but that doesn't help me any, right? And I can only do that with, I don't know, I guess I could do iPhone batteries. iPhone battery will last between 0 hours and 276 days. I don't think it will last more than that. Y'all okay with what I'm saying though, right? Plausible values. Plausible values, okay? Here we go. Plausible does not mean the same thing as possible. Plausible means I won't be surprised if it lies in it. I will be surprised if it doesn't lie in it. Each thing I say, guys, there's kind of two ways of meaning that, but I would not be surprised if it lies in it. I would be surprised if it didn't. There's a really good shot I hit it. Especially if I've done a really good sample and I've taken a good sample size and I've done everything I'm supposed to, there's a really good chance I hit it. I may have missed it though. I may have missed it. Possible means, whoa, come in, keep hitting that button. Possible means it has to be in there, and that's not true. We may not have hit it. Y'all okay with my terminology on that? These are the type, these little bitty things right here are the difference, right, between 5s and 4s and 4s and 3s. Those are the little bitty things like that that separate it. Most everybody understands what a confidence interval is by the end of this year. You understand I found an interval. I think that the population, I think that's what the population is, but it doesn't mean it has to be. I got a good chance that it is. Okay? A lot of pencils are going. Keep those pencils going. I'm trying not to go too fast. I don't want to go too slow, but yet I want to make sure you guys get this. Because why? You see it 3 more freaking times. You're going to see it all year long. And so you got to understand these things. Not just necessarily how to do them and what they're doing. You got to understand them in and out and everything else, because we all want 5s. We all want 4s. Or we all want 3s. And some of us are going to get 2s and 1s. It's okay, but we want A's too. So we got to understand this. So that's why I got to go slow. I always try to keep in my head every morning when I wake up, this is the first time you guys have seen this. 28 times 3 is a lot. I've seen it a lot of times. First time you guys have seen it. Now, when chapter 9 rolls around, guess what? Or chapter 10 rolls around, I go through it pretty quick, because it's not the first time you've seen it. Click. All right. We've talked about interpreting stuff in this class many, many, many times. In fact, we're going to spend April talking about all these interpretations, because you got to know every one of these interpretations. I'm telling you, on the test, this is 4 points. This is 4 points. If you miss this, I don't know how else to tell you, but this is a you problem, not a me problem. It's a question on the test. You will have to interpret that at least once. At least once. We are. You can be selfish and say, I am. Right? Y'all guys understand these interpretations. You don't have to state it exactly like this. You just got to get the main parts in there, right? So, we are, I am, we have done, I don't know what we want, but this is about as short as we can make it and still get all of our points. We are whatever percent they're going to give us. And they're going to tell you in the problem what percent to use. Most of the time, that is 95. Most of the time, that's going to be 95. Anybody have any idea why 95? Hit me.
It has to do with like standard deviations.
95 is what? 2 standard deviations away. Sometimes it's 99, which means we'll go to 3 standard deviations. Sometimes it's 90, but we don't want to ever go 68, because 68 is just 1, and that's not big enough. So typically 95, 99, 90 are the most common. However, I've seen 96 and I've seen 98 and I've seen 93. Sometimes they'll put some different numbers up there. They'll tell you in the problem. For class sake, I will always say 95. If they don't tell you, use 95. If they don't ever tell you, don't guess, just 95. So we are 95%. We are 90%. We are 99%. I am 99%. Confident. We're going to use the word confident. We're going to use the confident. That the interval, and you can write it in words, or that the interval, or you can say that. Okay, y'all with me? Whatever you got to do, but we got to mention this interval. However we got to mention this, we got to mention this interval. From here to here, or if you don't want to do from here to here and you want to just do the actual interval, you can do that, okay? We just got to get it in there somehow, some way, some form, some fashion. We are 95% confident that the interval from here to here, of course, it should be lower bound, upper bound, right? That's the way we do mathematics. It should be lower bound, not upper bound, lower bound. Lower bound, upper bound. Contains or captures. Captures. And now this is what's going to be really big. We got to talk about the population. And I don't like writing the word population. I just like writing the word true. Because true is a whole lot easier to write than the word population. But sometimes I'll get over anxious and I'll write true population. But somehow or another, we have to reference the population. If you don't reference the population, that's where you're for sure going to get dinged. Right? All this other stuff is kind of frivolous. I mean, we can say that several different ways, but we got to talk about the population. And then, guys, what are we talking about? We're talking about the population proportion or population mean. In this chapter, it's going to be proportion. In chapter 10, it's going to be means. But it still might be proportions. But whatever one you're talking about, if it's categorical data, we're going to use proportion. If it's numerical data, we're going to use means. But you got to say what we're talking about here. Chapter 12, that's going to be slope. However, we don't do confidence interval slopes hardly ever. And then context, right? Context. How many points I tell you that's worth? 4. On the AP test, what's that worth? It's its own. That right there, that statement is its own E, P, or I. That statement is always its own E, P, or I. Just by saying that, you're going to get an E, or you're going to get a P, or you're going to get an I. How are you going to get a P? You're going to mess up and leave the context out. You're going to not talk about the population. You're going to forget the 95, or you're going to forget the interval. You're going to forget something to not get an E. Other than that, you're going to get the E. Fair enough? 4 points on the next test. I promise you at least 4. Not to mention the multiple choices that's going to have this. What am I going to do with a multiple choice? Talk about a sample? Give you a different interval? I don't know what else you can do. You'll see some examples on your homework of bad stuff. Any questions about that statement? We are 95% confident that the proportion of, sometimes I'll say it backwards, that the true proportion of all students who attended class last week lies in the interval from here to here. Y'all see it? I said a little bit different than this. It's okay. We are 95% confident that the true proportion of freshmen who attended class last week lies in the interval from here to here. Sometimes I'll flip-flop that stuff. There's 28 of you cats in here. I don't know if there's 28 ways to say this, but there's a bunch of ways to say it and still get the E. Where do students mess up? Leaving the population word out. Leaving that true, leaving that all, leaving whatever that word is that you're going to use to make sure we're talking about the population. And then they'll leave out the proportion, or they'll leave out means. because those are things that make sure that the grader knows that you know what you're talking about. Very seldom do they leave the context off, because I've beat that into your brains enough that you got to talk about context. And very seldom do you leave off "we are 95%," because I don't know how else you can start off with it. Everybody okay? Here we go. Let me get this in your heads now, okay, while you guys have this down and while you guys are paying attention, and while this has nothing to do with probability. And this is one of the hardest things to not understand, or to understand, I guess. This has nothing to do with a 95% chance. Has nothing to do with chance. Let me put it in perspective for you. Okay? Some of you guys are applying to colleges. Some of you guys have got into colleges. Some of you guys are waiting to get in colleges. Most every college has an acceptance rate, yes? So let's just say, out on a whim, that they have a 20% acceptance rate. They have a 20% acceptance rate. You apply to that college. Do you have a 20% chance of getting in? No. You're either in or you're not in. We either hit the population or we didn't hit the population. It has nothing to do with a 95% chance. And that's one of the really hardest things for us to do. Why are we doing 95%? That 95 is giving me that interval. It's giving me that 1 standard deviation, 2 standard deviations away. That's what it's doing. It has nothing to do with me capturing the proportion or the population mean, whatever we're talking about. So try to keep that out of your head. And the college acceptance rates, I had a student come up with that, I don't know how many years ago it was, and it made so much sense of that. You yourself you're either in or you're not in. We either hit the population or we didn't hit the population. It has nothing to do with a 95% chance. And again, that's a really, really hard thing to do. And that's one of the things they're going to try to get you to, on multiple choice. They're going to try to get you to talk about chance of it happening. It has nothing to do with probability. Okay? We'll explain it in another 10 more slides or 5 more slides or 8 more slides or somewhere in there. We'll explain what it does mean. But this has nothing to do with we hit the population or we either did it, it's 100% or 0%. Okay? All right. Keep that in mind as we're doing these confidence intervals. That has nothing to do with chance. Don't ever say 95% of the time. That's where a lot of students, we are 95, there is a 95% chance we hit the population. No, that's wrong. But I promise you that's a multiple choice answer. I promise you that's a multiple choice answer. Out of the 5 choices you get, 95% of the time. Another one they're going to say is we are 95% confident that the interval from here to here will capture the sample. I'm 100% confident it captures the sample. The sample is what I'm using. Okay? So I'm not trying to capture the sample. I'm trying to capture the population. Okay, don't do it, don't do it, don't do it. It has nothing to do with chances. Don't say 95% of the time. 95% confident. Okay? All right. And then this right here, make sure we're always referencing that parameter. Make sure we're always referencing the parameter, not the statistic. Okay? That's another that will try to happen. Okay? Just make sure we're 95% confident we got the parameter. Again, the statistic, I know what that is. I know that information. This is on your notebook. This is in your notes. 2 weeks before the presidential election, a polling organization asked a random sample of registered voters the following question. If the voting was held today, would you vote candidate A or candidate B? The 95% confidence interval for the proportion. I told you guys, look, proportion. You're not going to have to get confused on is this categorical or numerical data. They're going to talk to you. They're going to tell you in the problem. Is 0.48 to 0.54. Interpret this confidence interval. Write it down. Go. Interpret that confidence interval. Try not to use what I gave you. Try to use what you think you already know. If you have to peek, write down what that confidence interval is. I want you guys to write it down because on the test, when I count off, you're going to say, I've never seen that before. And I'm going to say, you're lying. Because you have. Open up your notes. You wrote it twice at least. Anybody have a question about what you put, if it's good enough or not? Because you don't have to put exactly what I put. Look at how I wrote it this time. I wrote it completely different. We are 95% confident. I at least got the we are 95% confident. I don't want to say 90%, 5% sure, because you say that, you're getting dinged. That the true proportion of voters, I represent the population, and I said proportion, who vote favor candidate A. There's context, lies in between, or lies in 0.48 to 0.54. I hit everything I need to hit. I didn't hit it in the order that they told me to, but they don't care. There's not an order that they tell me to. The book always talks about the interval first and then. So the way that I gave it to you is the way our book talks about it. But a previous book always did it this way. Anybody have a question about what you can put or less than you can put or something? Is this enough or is this too much? I don't think there's such thing as too much. However, I do think there is such thing as too much. Anybody have a question about, hey, can I put this instead? Somebody shortened it yesterday for me that I thought was okay. Anything? Y'all okay? How many points on the test? At least 4. But I promise you, that's going to be a statement on one of your test points somewhere. Okay? All right, we're good. Beautiful. Beautiful. We are 95% confident that the interval from 0.48 to 0.54 captures the true proportion of all registered. Look, see, they emphasized it. We're talking about all, the proportion of everything, the true proportion, the population proportion of all. I don't have to state all that stuff, but man, I want to make sure that that grader knows that I'm talking about all of them. Don't reference the sample. Don't reference the sample. Okay, next question. You may or may not understand this. You may or may not get this. I don't know. I didn't teach this yet, but maybe you understand. What is the point estimate used to create this interval? I know it's p hat. Why? Because it's a sample. It's proportions. Anybody have an idea what the point estimate was I used? Talk to me. You're not wrong. Hit me. 0.51. How'd you get that? Right in the middle, right? That's the point estimate. That's where I'm going to start. Right in the middle. Right in the middle. Because then I'm going out right and I'm going left some. So that's right in the middle. Is that enough work? Actually, it is. Do I need to show 0.48 plus 0.54 and divide it by 2? No. No. We know you guys are pretty intelligent that you can say 0.51 has to be right in the middle of that. Should I say p hat equals? You should. Is it going to be wrong? I don't know what the rubric says. Right? I've taught you guys a lot about not leaving naked answers, and to me that's almost naked, but that's okay. They're not going to ding you for that part of it because it's almost common sense wise. Although one question on one of our tests was common sense, and they dinged you for it. Good enough of that? What's the margin of error? Again, I didn't talk to you about this margin of error, but if 0.51 is in the middle, that margin of error is what it takes to get to the minimum and the maximum. Which is how far away? It's not 0.06, guys. 0.06 is the interval. 0.06 is the interval. The margin of error is that wiggle room we're adding and subtracting. And yes, it's okay to abbreviate margin of error as MO. Everybody knows what you're talking about. You can abbreviate things if you want to. Is that enough work? Probably doesn't take a whole lot there. Okay? So that's good. So if I do this 0.51, add and subtract the 0.03, those are my values right there. Okay, that's how I'm getting my left and my right bound. That's how I'm getting my left and right bound. What are we going to do in 8.2 and 8.3? Show you how to get these numbers. Of course, you already know how to get this number because that's p hat. They're pretty much going to give us that number. We just got to know how to come up with that number. Okay? Happy, happy, joy. Everybody good? Click. Here's that work for that again. I don't think you need much work for it. I don't think that would be that big of a deal to talk about it. Now, this is different. This might take you a little bit to make sure you understand, because maybe what some of you guys are thinking is, I'm going to tell you, might be wrong. So pay attention here, listen, let's watch. Based on this poll, a political reporter claims that the majority favor candidate A. That's what the reporter claims. Majority favors candidate A. So candidate A has a good chance of winning. They favor candidate A. Use the confidence interval to evaluate that claim. P hat was 0.51. So it looks like candidate A is going to win. But what we know about confidence intervals, it gives me a list of plausible values. And what's plausible or what's possible besides that? Something below 0.5. Fair enough? I'm not too sure candidate A is going to win. I don't have convincing evidence. I don't have convincing evidence. I got some evidence, right? And we've talked a little bit about that with sampling distributions, about how I can get some evidence. And I have some evidence because P hat was 0.51. That gives me some evidence. However, that interval also gives me some evidence that it won't happen. So I don't know if this is enough evidence or statistical evidence to say. When would it be? If both ends were above. Okay? If both ends were above, I'd say we're okay. If both ends were below, I would probably say candidate B would win. But because we're centering that bad boy up, and I don't even want to say center. It doesn't matter if I center it or not. If it's in it, I have to say there's not convincing evidence. Nabisco or Sunshine, I think it's Sunshine, right? Their claim is 20% of Cheez-Its are broken, crushed, whatever. Good enough? I'll do a sample. If 20's in my interval, I can dispute it. Let me restate it. I can't dispute it. If I'm below, I'm good. If I'm above, I can dispute their claim. But inside it, anywhere inside it, I don't know if it's above or below it. Y'all okay? You'll see some stuff on your homework about that tonight. Because there are plausible values of P less than or equal to 0.5, the confidence interval, it does not give me convincing evidence. Okay? It doesn't give me convincing evidence. Okay, pencils, pencils, pencils. Let me slow down. New year, new us. Let's go. Sorry, man. Couple pencils, you good? Nope, still going. Still several going. It hurts when it's like January and it's like March outside. Man. Maybe it'll get cold. Good, 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 good. Click. Okay. Next thing we want to make sure we interpret, okay? This one's different. So this is where students will mess up. Okay, listen to two things. They're going to give me the interval when it's supposed to be the level. Don't give me the interval when it says level, and don't give me the level when it says interval. So make sure you interpret the correct thing, even though unfortunately I got them both green up here and it looks like it's interpreting confidence, but you got to make sure you understand it's level or interval. Interval is interpreting the interval. We are 95% confident that from here to here tells me that that's the population. Okay? This is the level. That level is at 95. It's that number, or the 99, or whatever it is. That's the level. Okay? And here's what this says. And I'm not too sure you want to write it down exactly like I do, because I say it different every single time. But basically, you need something like this. If I did this same process many, many, many times, if I did this over and over and over again, here's what they said. If we were to select many random samples, so somehow or another, guys, you have to talk about doing this over and over and over again. Okay? Doing this many times. Now, don't be scared. How many times are we going to do it? Once. If we did this many times. If we did this over and over and over again, and then from the population, and construct 95% confidence intervals. Okay, again, how you want to say this is going to be different. I can shorten this up by quite a bit. If I did this over and over again, if I use this same process and got many confidence intervals. Now, while you're writing, let's talk just a little bit. What do you mean I got many confidence intervals? If I got one confidence interval, why does that confidence interval different than the next one? Because this p-hat's going to be different than this p-hat, right? So this interval is going to be different than this interval because of sampling variability. So not every interval is going to look exactly the same. It's going to have a different starting point and a different ending point because it's going to have a different midpoint, right? Okay, so that's what I mean. If I did this over and over again, and I constructed many, many of these intervals, using each sample, again, I'm not too sure I'd even talk about that, in the long run, over time, this is something this book likes to say. I don't say it enough, but that deals with the probability. Now we are talking about probability. This is the key sentence right here. About 95% of the intervals. Now, I'm not an English guy, but I cannot think of a different way you have to say this. I think you have to have the word of the intervals. And it needs to be intervals because you have a bunch of intervals. You have a bunch of intervals. 95% or whatever percent it is, right, will capture the true whatever. 95% of those will capture or should. How about that? Would. I'd probably say should. But again, schematics, right? Whatever. As long as we kind of get it close. Most everybody does really, really well with the context. Most everybody does really, really well if we did this over and over again. And I don't know how, if you start off with, if we did this over and over again, and we did this many, many times, AP will talk about, if I constructed 100 confidence intervals using the same method, at least 95 of those intervals. This is, if you can get that part right there, I think everything else is going to kind of fall into place. Of the intervals. Intervals means I have several intervals. This, I know you can shorten up some. Let's go back to what I talked about earlier, guys, about getting into college, yes? You yourself are either in or you're not. There's not a 20% chance you're in. You either got in or you didn't get in. However, if you and 100 or 99 of your other buddies applied, there's a 20% chance or 20% of those will get in. Follow that, right? So You yourself, you're either in or you're not in. One confidence interval captured it or it didn't capture it. However, if I have 100 confidence intervals, you have 100 students that apply for that college, 20% of those will get in, 95% of these will capture the true population proportion or mean or whatever it is. Okay? Getting those two, that's hard. That's hard for a lot of students to accept, and it's hard for us. Like, that means the same thing. There's a 95% chance. No, that one interval is not a 95% chance. If that one interval is part of 100, there's a 95% chance that would be part of it. So it starts to get a little confusing. But as long as you kind of remember this all together, you'll be okay. It does get a little confusing. This is going to validate what I'm saying, okay? One particular confidence interval is calculated. Once it's calculated, the endpoints are set. They don't move. The endpoints are set. The population is set. The parameter is also constant. A particular confidence interval either includes the parameter, 100%, or it doesn't, 0%. Here we have this over here, guys, a visual. Here is the population. Here is the sampling distribution. Here is mu, and here's p hat. Okay? Here's one. I think they used X bars. Yeah, they used mu. So here's one X bar with a plus and a minus. Here's another X bar with a plus and a minus. Here's another X bar with a plus and a minus. Beautiful. Caught it, caught it, caught it, caught it, caught it. That bad boy right there missed it. So if this was 100 confidence intervals, one of them missed it. I must have done a 99% confidence interval. Fair enough? Does it mean I did that? No, I could have done a 98, could have done a 95. However, one of them missed it. What if I captured all of them? I was lucky. By chance, probability. Good enough? One confidence interval either captured it or it didn't. One captured it or didn't. This one here didn't. If I did it a bunch of times, that percent should capture it. Beautiful. Okay, here's where I emphasize this college acceptance rate, right? Some colleges have a 10% acceptance rate. That doesn't mean you have a 10% chance of getting in. You either get in or you don't get in. However, if you got 100 of your buddies or 99 of your buddies, 10 of those should get in. Should. In the long run. Does that mean 10 will? No, it might be 9 this time, but it might be 11 the next time. If it was 1,000, I don't know if 100 are getting in, but should. Same presidential election. 95% confidence interval. Interpret that level. Write it. Interpret that level. Write it the way that you would write it. Interpret that level. Interpret that level. Write it the way you would. Decide if it's good or bad, what it's missing, what it's not missing. Look at mine and what I wrote if you want. Like I said, guys, 20-something years of teaching this same course, and I probably never write it the exact same way every time. But I will guarantee you, I will always see of the intervals, the true, you got to talk about the population. You got to talk about the population. They'll try to get you. 95% of these will capture the sample. No, it will always capture the sample. The sample's right in the middle of that stupid thing. Make sure we always talk about context. It's that first line, first 8 words or so, that's probably going to be different for 28 of you cats. Anybody have a question about what they put, if it's acceptable or not acceptable, or something that I could do different? Anything, anything, anything. Uh-oh. Guess what? Guess where we're at? 8 points next test. I promise you, you'll have to interpret each one of those. About the only thing that students mess up on is they flip-flop the interpretations. They put one where they're supposed to put the other. Every once in a while, we forget the population. We forget something small. Most time, you guys do a pretty good job of it because I'm telling you exactly what's going to be on the test. So you either do a good job of memorizing it, or you have it written in your calculator, or you got it somewhere that you need. You got it. You got it. Anybody still writing? Anybody have a question about it? Anything at all about this? Beautiful. Beautiful. All right. The confidence interval does not tell us the probability that a particular confidence interval captures it. I can't emphasize that enough, right? Grading AP tests and talking to other teachers and talking to students and then grading your tests, that is probably the most messed up thing. There's a 95% chance. The only time we're dealing with probability is when I do this over and over and over again. That's what probability has to do with in the long run. One time is not in the long run. Okay? One time is not the long run. All right. Last thing we need to talk about today. And most of this you already know. Okay. In general, guys, we prefer a small margin of error, a small interval, right? The smaller the interval, the better information we have. If the percent of cheese that's broken is between 20 and 80, that doesn't help me a whole lot. That's either a lot or not very many. But if it's between 30 and 32, now that helps me. Like I figure about 30% of my cheese is going to be broken. We prefer a smaller margin of error. All right, softballer. I'm giving you that eraser, and you're going to throw it at my board, and you're going to hit that circle, or miss that circle, I don't know. No pressure. Now, before you do it, what are the chances you hit that circle? That's not very nice, even though she's a girl. I say that every year because it's fun. I coach girls. Girl dad. What are the chances you hit that circle?
80%, 85%. No, 90%.
9 out of every 10? 99 out of every 100? 95 out of 100? Just give me a number. That's not wrong or anything.
90.
Now do it. No pressure. Jackpot. Good enough. Hit it. Everybody okay? Good? Okay. Beautiful. I'm not done. As confident or not as confident? Not as confident. What happened to my interval? Your confidence will decrease. Fair? I'm going to ask you guys to predict my age. Predict it. Some of you guys know. So if you know, don't worry about it, but just play along. Predict my age. How confident are you can hit it? I'm going to give you plus or minus 5. Now how confident are you can hit it? I'm going to give you plus or minus 10. Now, how confident are you hit it? What happens to the interval, or happens to your confidence as the interval gets wider? Goes up. What happens as the interval gets smaller? Your confidence goes down. Okay with that? If you know that right there, and you can associate those two things, that is one way that we can control the confidence interval. The confidence level decreases, the interval has to decrease. And on the flip side of that, if the confidence interval increases, the interval has to increase. Remember what we did, guys? We did this over and over and over again. So if I'm going to capture the true proportion, I have to capture it more times. And if I'm going to capture it more times, I got to make it wider. I got to make it wider. So the level and the interval go hand in hand. If you increase it, it increases. If you decrease it, it decreases. That's what's nice, but at least thinking about those two things, throwing the eraser at the board, and I got a professional softball player trying to throw it, didn't matter. Okay? We either hit it or we didn't hit it, but we got the chances if I did it in the long run. Kind of see how all this stuff ties into actual common sense type stuff, right? My age, if I asked you to hit it right on it, I don't think you were very confident unless you knew it. 5, you were more confident. 10, you're pretty darn confident. If I gave you 20 and you missed it, you're just really a brown noser or idiot. Y'all okay with all that stuff, right? There's one other thing that you guys can control this with, and you already know this one because we've talked about it many, many, many times. What do we know about the sample size? As my sample size increases, what happens to my variability? Decreases, right? So if my variability decreases, guess what happens to my interval? Decreases. So that's on the flip side. So how I'm going to throw the pin? I used to throw a pin and hit the back wall, but I had somebody in the back do it, and they hit somebody in the front row and about poked their eye out. So I got in trouble for that. I don't know why. So I go to a soft eraser and put somebody in the front. Anyway. Here's an 80% confidence interval. There's a 95% confidence interval. I don't want to say you have a better chance, but there's more likely that confidence interval is inside it if it's longer, right? As the sample size increases, that decreases the width. So that's opposite of the level. As the level increases, the interval increases. As the size increases, the interval decreases. But you already know that, or kind of when we start associating all this stuff together, because you know that as you increase that sample size, that's going to decrease your variability. It's going to decrease that error. And if it decreases all that stuff, it has to decrease that margin of, that level, the margin of error. The flip of these could also happen, right? So they'll go either way. There's basically 4 questions out of this. There's 4 questions out of this. Now, what happens if I decrease this and decrease this? At some point, it's the same, right? They're not going to try to trick you to that. They're not going to say, I don't know if it increases, but that's probably what you'd have to say. I don't know if that increases or decreases because we've helped one of them, but we hurt the other one. So they're just only going to talk about one of these things. Okay? Or they might say, what are 2 ways I can decrease this interval? What are 2 ways I can decrease this interval? Increase my sample size, decrease my level. Yes, no, maybe. Y'all okay? Good day today. Y'all remember this from chapter 7, just to make sure, right? If I want to cut it in half, you have to quadruple it because it's a ratio, 1 over the square root of n. Remember, it was standard deviation over the square root of n. Remember, it was p, 1 minus p over n square rooted. So because this bad boy right here is square rooted, if you want to cut it in half, you have to quadruple it. If you want to cut it into a third, you got to multiply it by 9. If you want to cut it into a fourth, you got to multiply it by 16. So just remember that too. That comes up just enough where you got to try to remember those things. Okay? Yada, yada, yada. Project surveyed a random sample of 25 students. That's not a whole lot of students. I really wish that they would take a bigger sample size than that. But they sampled 25. One of the questions was, what is your GPA? The 90% confidence interval from, wow, 0.4 to 0.72. That's a pretty big confidence interval. Captures the true proportion of all students with a GPA greater than 3.0. Again, recognize that we're talking about proportions. Everything's in decimals. Okay? They're not going to try to trick you. I told you when we first started this, one of your first jobs is to decide on, is this categorical data or numerical data? Because if it's categorical, we got to go this way. If it's numerical, we got to go this way. And it's not a tough decision. It's going to be written in the problem. Explain what would happen to the length of the interval if I increased it to 99%. I was at 90%. I will have some students say it will increase by 9%. That's wrong. Don't say that. All you got to say is it will just increase. Because you have a larger confidence level, it will increase the margin of error. It will increase the interval. The confidence interval will be wider because increasing the level increases the MO. Okay? Wider. Is that enough? I don't know what the rubric's going to say. Probably not enough. You probably want to explain why it's wider, because somebody could guess wider. Somebody could guess wider. That doesn't tell me you understand what's happening. Wider because this happened. Oh, now you know why it's wider. That does tell me something. That does tell me that you understand. Why can't I just say wider? Wider is the answer. Somebody could guess wider. You only have a choice, wider or narrower, or stay the same. Everybody okay with that? This one says now that I had 25 students, I went up to 100 students. I kept it at 90%. Luckily, I kept it at 90%, because if I changed that, you changed two things, and I don't know exactly what it did. But because I went from 25 to 100 students, I now quadrupled it. Therefore, my margin of error will be cut in half. Therefore, my interval will be half as wide. However you want to say that. The confidence interval will be half as wide because the sample size increased by 4 times. Because I quadrupled it. Because 25 times 4 is 100, and the square root of 4 is 2. I don't know what you want to say. You can start going into a whole paragraph and a half, and you probably said too much. Questions? Y'all good? Happy, happy, joy, joy? Let's bring something in from first semester. Let's bring something in from first semester. Describe one potential source of bias. Let's go back and read the question really quickly because I covered it pretty fast. As a part of a project, Ellery surveyed a random sample of 25 students from her school. One question required students to state their GPA out loud. So what type of bias could have happened? Response. Can non-response happen? No, because if non-response happened, I can't get any information from that cat. Okay? Now, so response bias could have happened. I answered it not truthfully. But guys, every time you talk about bias, you got to talk about what? How it differs from the truth. So is that value over or underestimated? It's overestimated because I'm more than likely to tell you that I'm smarter than I am. I'm more than likely to over-exaggerate my GPA than I am to under. Again, that's just stuff from first semester that we want to make sure. Sometimes I'll throw that in as we go because I want to have the aha moments. I hope you can identify the appropriate point estimator, my starting position. I hope you can interpret a confidence interval in context. If you can't do that by now, we for sure have a you problem, not a me problem. I hope you can determine the point estimate and the margin of error from the confidence interval. You'll be able to do that after the homeworks for sure. I hope you can use the confidence interval to make decisions. Hopefully homework will help you with that. I hope you can interpret a confidence level. Again, make sure you understand the difference between level and interval, okay? Describe how a sample size and the confidence affect it. If I increase it or decrease it, what happens? And then explain how particular issues like non-response, undercoverage, and response can affect the interpretation. I either overestimated or underestimated the truth. Beautiful. I'm going to go here. I'm going to go here.